Section 8: El Niño and Ocean Circulation. Digging deeper. El Niño and non-El Niño conditions. In the Investigate, you analyze data sets of sea surface temperatures in El Niño and non-El Niño years. You looked for and identified patterns in the data. After this, you plotted the data onto maps. You interpreted the maps to explain how sea surface temperatures vary during an El Niño event. Finally, you analyzed sea level data that was collected by the Topex Poseidon satellite during a severe El Niño year. You interpreted the data to track the movement of water masses of different temperatures. This data showed that an increase in warmer water led to a change in the topography of the ocean surface. This digging deeper will help you to understand more about what goes on during El Niño events. Most of the time, along the coast of Peru in South America, there is a strong northwest flowing current. It causes upwelling. This brings deeper water that is rich in nutrients up to the surface. These cold waters support a rich population of fish. An El Niño is a condition occurring every 3 to 6 years. The sea surface temperatures in the eastern equatorial Pacific Ocean off the coast of Peru are much higher than other times. During these times, the fish population is much lower. It is lower because cold, nutrient-rich waters are no longer brought up to the surface by upwelling. Peruvians have known about El Niño conditions for centuries. Yet, it has only been in the past 100 years that geoscientists learned that an El Niño involves certain changes. These include changes in ocean circulation and sea surface temperatures. There are also changes in climate. These changes occur all through the entire equatorial Pacific. This is an area that spans a quarter of the way around the world. An El Niño is often called an event. It is contrasted with normal conditions in the equatorial Pacific. It is more realistic to think of El Niño and non-El Niño conditions as two different states of the ocean and the atmosphere. These states alternate with each other as years go by. The change in conditions is not regular. Non-El Niño conditions usually last about 3 to 6 years. The equatorial Pacific is in the El Niño state about 20% of the time. Geoscientists still do not know exactly what causes the switch between non-El Niño and El Niño conditions. However, the driving force is related to a weakening of winds caused by changes in the atmospheric pressure gradient across the Pacific. The Southern Oscillation. Most of the time, the eastern equatorial Pacific has a very dry climate. The western equatorial Pacific, in the area of Australia and Indonesia, has a very humid and rainy climate. Long ago, a climatologist named G.T. Walker noticed this condition. He thought that this difference in climate was a result of a huge circulation cell. Air rises up in the western Pacific. It causes a lot of rainfall. The air then flows eastward at high altitudes to the eastern Pacific. Then it slowly sinks back to low altitudes. It moves back to the western Pacific as easterly surface winds. The reason the eastern Pacific is usually so dry is that the sinking air prevents condensation and rainfall. This circulation cell in the equatorial Pacific is now called the Walker circulation. During El Niño conditions, the atmospheric circulation in the equatorial Pacific changes greatly. The area of humid rising air and lots of rainfall shifts eastward. It shifts to the central and eastern Pacific. The western area is unusually dry. At times there is extreme drought there. There are heavy rains and floods at times in the areas along the west coast of South America. These areas are normally very dry. The easterly winds that blow near the equator get weak and sometimes even reverse. The equatorial Pacific Ocean. During non-El Nino years, the easterly winds move warm surface water toward the western boundary of the Pacific. Sea level is then slightly higher along the western boundary of the Pacific. This is partly because of the push of the wind on the water. It is also because the water is much warmer. You know that water expands as temperature increases. This raises the sea level slightly in the upper layer of the ocean. Also, the thermocline is much deeper in the western Pacific than in the eastern Pacific. Upwelling along the coast of South America causes the ocean surface to be so cold because the thermocline is very shallow. This allows the upwelling to tap cold water from below. During El Nino years, the equatorial Pacific Ocean is very different. When the easterly winds weaken, warm water moves eastward from the western Pacific area. The warm water moves all the way to the west coast of South America. At the same time, the thermocline gradually deepens from west to east. It does so in kind of a wave-like motion. Upwelling continues along the west coast of South America. However, because the thermocline is now much deeper there, warm water instead of cold water is brought up to the surface. Not all El Nino events have the same strength. The graph in Figure 4 shows how El Nino events can vary. The 1997 to 1998 El Nino event that you examined in the Investigate was one of the strongest in the last few decades. Cause and effect. Which comes first? The change in atmospheric circulation or changes in the equatorial ocean? The changes in the atmosphere and the ocean that are involved in the beginning of an El Nino event seem to develop at about the same time. Therefore, there is no easy way to decide which is the cause and which is the effect. Geoscientists are still not sure about this. One way of thinking about this is that the ocean and the atmosphere in the equatorial Pacific form a coupled system. The system can exist in two different states. Also, some minor factor can switch the system from one state to another. Much more research is needed before the geoscientists have a full understanding of El Nino. During a standard El Nino event, the maximum ocean warming occurs in the eastern equatorial Pacific. Since 1970, one of the strongest El Nino events occurred in 1997 to 1998. Previously, the El Nino event in 1982 to 1983 was the strongest and caused both climatic and economic problems that cost over $8 billion in damages. In 2015, a strong El Nino returned and continued into 2016. The average sea surface temperature in this eastern Pacific from June through August 2015 was 1.22 degrees Celsius above normal. This may not sound like much, but it is the third highest value since 1950, after 1987 and 1997. Where the average in sea surface temperature was 1.36 degrees Celsius and 1.42 respectively. For the atmospheric part of El Nino, values were the second lowest on record after the 1997 event. Scientists look at a number of different characteristics to compare El Nino events. An important measure is how much the trade winds are disrupted. Variations in atmospheric temperature and pattern of precipitation are also considered. No two El Nino events are the same in terms of their timing and magnitude. Since the early 1990s, scientists began to recognize a new type of El Nino event nicknamed the warm pool El Nino. Unlike the standard El Nino events, the maximum ocean warming occurs in the central equatorial Pacific rather than eastern Pacific. These events have been observed in 1991 to 1992, 1994 to 1995, 2002 to 2003, 2004 to 2005, and 2009 to 2010. Scientists are trying to learn more about the cause and their impacts on climate. Summary of the El Nino hazards. El Nino impacts are not guaranteed and vary from region to region. El Nino can ramp up the hurricane season in the Pacific by providing lots of warm water to power storms. Droughts can result in crop failure and severely affect the food supply chain. Droughts can result in increased wildfires and a lack of water to stop them. Flooding and landslides due to increased precipitation can result in the disruption of essential services as well as the loss of life and property. Prolonged wet periods can cause a rise in waterborne diseases, including malaria. Warming of Pacific waters can have a big impact on the biosphere, causing coral bleaching episodes, coral die-offs, food shortages for ocean mammals and birds, and problems in fisheries and seaweed farms. There's a picture of the effects of the drought